Good evening, good morning, good afternoon, and thank you for joining this Neo4j Live. Today, I'm super happy to have Ravi and Sid, my Neo4j colleagues, join me today to talk about their latest book, Building Neo4j-Powered Applications with LLMs. So I'm super happy to have you too. Hi, Sid. Hi, Ravi. Thank you for joining. How are you doing today?
Hi Alex, doing good, amazing. Super excited to do this Neo4j live session with you.
Can you hear us, Ravi? I can hear you. Ravi cannot hear us. Okay, maybe he is technical issues. So let's give him a moment to reconnect to our stream here, and hopefully we can, get him, to hear us. We could hear him. I think what we could hear was his typing.
Yeah, that's right. How are you doing, Alex, by the way?
Yeah, good, doing good, doing good. It's been a couple of busy weeks, surprisingly, even that I thought, okay, for August it's going to be a little bit more quiet, but it's been busy, and now it really kicks off. So we'll be very very busy in the coming months, this and the next, I think. With I think at least here in Europe, the highlights are the AI engineers event in Paris, and AI engineers globally also. The two AI engineers, I guess, it's the AI engineers San Francisco is happening, I think, next week, and then a week later, the AI engineers Paris is taking place. So that's going to be big.
Nice, interesting. I'm super excited. I'm super excited for Nodes as well.
And
That's
knows
coming
as
up.
well. Yeah.
I think we all will be super crazily busy until Nodes,
Yeah.
with multiple conferences running around across the globe, in Americas, in EMEA, and then in APAC as well.
Yeah, absolutely. And I was meaning to talk about this at the end of this, but since now Ravi is rejoining, maybe I'll pull it forward a little bit. So, like as you mentioned, Nodes already. Road to Nodes is starting. Oh, here he is. Hi, Ravi. Can you hear us now?
Yeah, I can hear you. Sorry about that.
Wonderful. Well, then let's go back to here. Welcome, and thank you for joining, Ravi and Sid. It's great to have you too. Great to see you, and to talk a little bit about your latest book that's been out. Well, how long now? 2 months or something?
Yeah,
Maybe?
it's around 2 3 months here.
Two,
Yeah.
3 months.
Cool. So yeah, I'm happy to talk to you about this book. So we'll make it a little bit conversational, more conversational this time around. We have a couple of questions, or I had a couple of questions prepared, but obviously, as always, this is an open invite to everybody who's watching this right now. I'd like to hear your questions, hear your comments. I don't know if anybody who's watching it right now has already read the book. Maybe that would be interesting to comments. But also, if you haven't read the book, what are your questions on the topic to Sid and Ravi? That would be nice to hear. And yeah, maybe before we kick things off, do you want to share a little bit, about yourself, who you are, what you're currently doing, and then maybe what made you write this book? Maybe it's three questions in one, but maybe let's start a little bit with what's it you're currently doing? What's on your daily agenda, basically? Sid,
Mm,
do you want to start?
yeah.
Sure, I can. I can. So I'm Sid. I'm based in Bangalore in India. I take care of developer relations activities for Neo4j across Asia Pacific. Uh, I start my day with thinking about meetups and conferences, and my day ends with that. That's what I do. I mean, understanding what the developers really need, their pain points, and then making sure from Neo4j we can give them the best experience around graph technology. That's what my agenda for the day, for the week, for the month. All in all, it's all about doing meetups, doing conferences, speaking at these meetups, speaking at these conferences. I do a lot of talks and workshops across various locations in Asia Pacific. be it Singapore, Australia, India, all these countries in the region, and then making sure that the developer voice is also heard within Neo4j. So taking their inputs and then sending it back to the team internally, what needs to be updated or fixed, or what needs more improvement. Um, at the same time, making sure that whatever we are launching, or we're kind of coming up in the field of graphs and GenAI, we take it to the developers and help them educate on graph technology. But at the same time, like the recent focus has been heavily on GenAI. So what do we have in the GenAI world for the developers out there, be it GraphRag or be it on the agentic side of things?
Nice.
Yeah, so my name is Ravi Anthapu. I'm located in New Jersey, US. I've been with Neo4j almost 7+ years. My role has been, initially I started as a um, um, professional services. I used to help customers actually take the graph technology to the production, implementation solutions, helping them coding along with them, or deployment architectures, different aspects of it. Of late, my role has been mostly helping customers actually. Okay, you are using Neo4j. Okay, you are stuck. What do you need to look at? How can we help you to get the graph to this thing? Especially with the GenAI explosion, the graphs are becoming and more valuable. Ability to leverage the what graphs can give you in a much more effective way. So that's where the idea for the book also came into picture actually. So Sid started, I think Sid, you reached out to Pacti, I guess, to do some ideas actually. So they came back and talked about Gen AI, this thing. So when he reached out to me, I was looking at some aspects of it, especially with the graph data science, and how can we mix a lot of different aspects of it. That's where when he mentioned Gen AI and Neo4j knowledge graphs, it there are few ideas we wanted to look at actually. What would be a good end-to-end application would look like with GenAI? Is it just querying with GenAI, or can GenAI help to enhance some things in the knowledge graph? So that's how the whole part of the book idea, and that's where the all the content into the book came into.
Exactly. Yeah, I mean, it was last year, sometime in May or June. That's when Pact folks reached out. They wanted me to write a book on GenAI. Um, uh, I mean, I was confused. Like, what should I really talk about? There was so much of content around
Yeah.
GraphRag. There was so much of content around Neo4j and knowledge graphs already there. But what would really stand out? And at the same time, I was also experimenting with the AI GenAI applications for a while. I mean, these were like small prototypes, passion projects of sorts, like my own Mahabharata chatbot or a movie recommendation chatbot, um, just built from like basic toolings. But one thing which I kept running into every now and then with the Mahabharata chatbot or the movie recommendation or any of those applications was that yes, LLMs were powerful, and they still are powerful. Um, but without this structure to the data, they started hallucinating. They started losing
Yeah.
context, and that's when I realized like knowledge graphs with Neo4j are the real missing piece in that puzzle. They can add relationships, context, and reasoning to it. So the book came out of a need to share this as a playbook. I mean, Ravi can also kind of correct me if I'm wrong on this, but I initially wrote it as a playbook itself, that how developers can combine LLMs, embeddings, and graphs to build applications that aren't just impressive demos, but actually reliable, explainable, and
Mm.
production ready. So that was the initial thought, to write like a playbook of sorts, but then eventually, thanks to Ravi, it kind of evolved, but not just as a GenAI book, but rather building GenAI applications that you can trust, that are production ready, that are reliable and explainable.
Yeah. In general, just to add to that part, what does knowledge graph means? Why do you want to think about it? What do you want to think about it? And how can you realize the knowledge graph. So we went back to bit of a basics actually. Why do you need knowledge graph? What does knowledge graph mean to you? So that's how we started actually the introduction basics aspects of it. Then we went into LLMs actually. So if I'm doing just a search, how does it work? No, I want to build more complex application scenarios. Where does LLM fit? How does LLM can help? And where does knowledge graphs and what other surrounding frameworks that are useful to help us? For example, um, one use case in the one of the use cases of what we are doing is LLM is not used to provide search results, but LLM itself is used to enhance the data that is in the graph to this thing. Then we are using graph data science workflows to build a more robust recommendations. So those whole flow aspects of it, LLM is not one use use case scenario. They can play a very integral role in whole end-to-end building applications, different complex applications.
Yeah, cool. That actually is, you really led me into the next question I had is about, you mentioned knowledge graphs and we see this rise in AI and the you mentioned this before, all these buzzwords, all these topics. You hear about context engineering, you hear about GraphRag, then you hear agentic AI, then knowledge graph comes around, then there is memory in place, and then various other chatbots and tool integrations and all these things, and it's like an onslaught of trends and themes, and how do you see you identified a knowledge graphs a little bit. How do you see knowledge graphs, AI? How do you see that? And what's the, from your point of view, what's the important bit that people should really be, thinking of when they think of developing an AI application?
For, for me, especially actually the graph as a starting point, as especially how do we look at the graph is the biggest thing, because after once your graph structure, how you are storing the data in the graph, how are you consuming it, can make it actually very powerful, or sometimes actually it can be a bit of a drag also. That's where because we the in the chapter 3 we started with actually why we want to think in graph, because there is a different graph is a different paradigm. Graph is a new paradigm. As such, it will let you express the data the way you want to see it, the way you want to consume it, the way you want to understand the data. So that is actually a unique paradigm with the graph. That's where if graph as a structure is able to represent the data, even LLMs can understand it much more easily than structuring pretty much similar to RDBMS aspects of it. So graph, most of the times actually when I see people trying to use graph, oh, I have tables, I have these tables, okay, these tables become nodes, the giant table become relationships, I have a graph. What that makes it is you are taking a RDBMS data, putting into graph as it is. That means you are still limited by the how you are thinking in relational aspects of it. So graph is actually trying to break out of that mold. Once I am able to put that actually graph as a structure, I can actually express what my graph data model is as an English language. That means LLMs can understand my graph. If they're able to understand my graph well, they can retrieve the context data much more efficiently. That's why the RAG becomes more and more valuable and efficient once the data is in graph, because I can express the data as an English language.
Mm-hmm. And anything to add, Sid, to that?
I mean, yeah, I mean, Ravi covered almost everything. He talked about that LLMs are incredible at generating language and reasoning patterns. But what they miss out is a deep context on the data. Oftentimes people confuse that with let's say long-term memory. Now LLMs have long-term memory, but can you feed in the entire data at a single go? Well, you can, yeah, or you would do that, but then it's not a viable solution to feed in the entire data. But you want to extract the relevant context, from a chunk, from a piece, and make sure that you pass it to the LLM. And that's what LLMs usually miss out. But knowledge graphs really provide that solution, that structured context, that explainability over there, that ability to explain why these two things are related, and uh, not in terms of, okay, these things are similar, or this looks like that. But graphs can handle furthermore. They can say, okay, these things look like that, but they can also connect to that with this. So the why part of it, which is essentially what GraphRag is, and the book also covers extensively on GraphRag, um, that how knowledge graphs kind of help you in achieving GraphRag, uh, and making sure that you can get the semantic retrieval from vectors, and at the same time you can get logical, explainable reasoning from graphs. So the combination of two is kind of the sweet spot over there, over here. And this combination actually makes the GenAI applications not just smarter but also more trustworthy for our real world use. Uh, Knowledge graphs are amazing. They have been in existence, but then with GenAI now, with LLMs combined together, they are, I think, they're incredible.
Yeah, cool. And then when you then pick a knowledge graph and with AI in mind, or with an AI application in mind, is there anything you can sort of recommend to people to say, okay, this is how you should build it. These are maybe some important bits that you should consider when you align a knowledge graph with an AI application?
One aspect I would say is where does LLM fit? How do you want to leverage LLM? This is where actually, when we split the chapters in the book, Sid concentrated more about actually, okay, how do I build a search application? So can I leverage LLM to give more relevant search results and other aspects of it? So for him, the LLM becomes the endpoint, not the anywhere in the middle. For me, actually, when I looked at the recommendation applications, so where I looked at LLM is, for example, for the recommendation applications, actually, I'm using the purchase recommendations. So we took the H&M retail data because it has enough information. So when I looked at the recommendations, actually, okay, I want to understand how summer purchases are happening, so that when the next summer, if somebody wants to make a purchase, what kind of recommendations I can give. So when I looked at the summer aspects of it and use the LLM to summarize the purchase details, and then making it to go through our graph data science workflows, the communities and grouping of the customers actually are very, very interesting. So just to give you an example, a lot of people are buying the baby clothes. But once we ran through LLM and graph data science, actually, it put the new mothers into one category, the grandmothers who are buying the kids clothes into separate category. If see, it actually makes it more and more robust, actually, because of the variance, how the LLM looks at the data makes it actually, the community is actually much more robust. Whereas if I had run through basic GDS other workflows, actually they may have come into one community together. So it actually opens up new ways of looking at the data. That's where the strength of LLMs actually is. Okay, how am I using LLM? LLM is not meant to be used, actually, I want an exact answer. I want what is my closest answer. Then actually, because of that variance, the next workflows, actually, they're able to pick up that variation aspect of it and give you better communities and better recommendations. That's where actually, so understand where LLM can fit much better, and so in which places it can contribute more in terms of understanding the uh, goal towards our solution. Yes,
Super.
Sid, anything
Yeah.
you have?
Yeah.
I think Ravi covered up again most of it. What I loved about working with Ravi, especially on this book, he brings in wealth of knowledge around graph data modeling. In fact, he has written a dedicated book on graph data modeling. And I would rather advise anyone who wants to think of GenAI applications, or be it just graph applications, leave GenAI on the side for now. Just building a graph application or using Neo4j or graph databases, the first thing that I would rather say is to model your database, like in a good way. And Ravi is an expert on that. How do you model it? What are the constraints that you need to put? Where you should put constraints? Where you should index it? Where you should not index it? I mean, it matters a lot on the retrieval side later on. And the way you model, the way you see the performance of your queries, that makes a lot of difference in your, even in your GenAI applications later on when you're doing a retrieval. That's one, the modeling part, the graph data modeling. So you should spend good time in graph data modeling and model in a graph way. Do not start with tables and rows and columns. You're working with graphs, so essentially think of it in a graphs way, graphs format. Start thinking with nodes and relationships in that kind of a format. So that's one. The second thing is, in terms of retrieval, usually people just think of a graph retrieval in the GenAI application, but rather I would suggest to do a hybrid retrieval, which is a vector plus graph retrieval, so that you can store your embeddings as properties in your graph. And then you can also, so that's a semantic part of it that's handled. And then you also do the additional graph traversal. So make sure your chunking is done well. You also can generate community summaries around it if you want to, and then you start doing the graph traversal. So the hybrid retrieval, which is a combination of vector plus graph retrieval, that works the best, or in most cases that's what I've seen works amazing, rather than just using a vector only retrieval or a graph only retrieval. So don't go purely with that. So if you're building a GenAI application, it's rather to go with a hybrid retrieval. I think these are the two things that I would love to underscore over here. But definitely, if folks out there have not read Ravi's book on graph data modeling, you should go and grab that. Or even in the book, Ravi talked extensively on graph data modeling, taking some pieces from his first book and kept in this book as well. So this book also could be a good starting point for you for understanding how to model your data well. So that's a crucial piece to start with.
Totally. Yeah, I couldn't agree more. This is really important. We have a couple of questions, so maybe we can dive into those a little bit. So, and I know it's a difficult one. So Illa Pilla on YouTube asks, can you give example or details when the Graph LLM does work and doesn't work? And it's like this, it depends sort of questions. So it's really tricky, I guess. But do you have anything that comes to mind where you say, oh yeah, that's a good example for? I mean, probably good examples are easier to share.
I can give some examples actually, because
Ravi will
this
have
is how
tons of it.
few
I'm
customers
sure
are
Ravi will
using
have
it. What customers are trying to do, some people actually trying to do is, oh, I have this data, let me give this data to LLM and let it generate a graph data model. That's not the use case. Because who understands your data better? Do you understand your data better, or the LLM understands it better? So that is where, as such. So, and few other scenarios what I have seen is actually trying to, okay, I don't want to learn querying, let LLM do my querying for it. So this is where, if model is not good enough, LLMs may not be able to understand that. So they may not be able to generate the queries this thing. So that approach is where is the big problem. But if you have a good graph data model, you are using the LLM to understand it better and this thing, so then it will work actually. Because the use cases, what we put it in the book, that's what we see is actually best way to use the graph LLMs actually into your graph RAG approach or knowledge graphs and other aspects of it. But letting LLM be the starting point to generate a graph data model is not its use case.
Anything you want to add here, Sid, from your point of view? Anything you've seen where you think, okay, this is a great use case?
I think it works in almost all the cases. Graphs and LLMs together work in almost all the cases. Where it doesn't work, I cannot think of it, but maybe in like simpler use cases when your data is maybe not that big enough, or you can just make your ends with just a regular relational database, or with just anything that works with just a semantics. That may be the reason why you should not think of graphs. But if you have more than semantics, more than you want to retrieve the context to it as well, I'm sure graphs is definitely a compelling choice, which you should consider, and not just think of vectors or semantics as the only option, or just relational or document database as the only option for you. So I mean, it varies a lot. It may not be the right fit for, let's say, um, I don't know, for certain use cases when where you would want to use a dedicated database, like some other use cases, where other databases might shine. But I think in most use cases, graph databases work well. Fraud detection, your community detections, or your personalizations, 360 customer 360 recommendations. Or in almost all the use cases, we have seen GenAI and graphs working well.
Yeah, cool. More of a comment than a question comes from Manjunat, and he says he read the book and it's an excellent guide to graph RAG, and with a great progression from RAG basics to building complete systems with Haystack and Neo4j. The practical examples and cloud deployment chapters are really valuable. Highly recommend for combining knowledge graphs with GenAI. So it's really nicely written. Thank you very much for that comment. If you have more questions, let us know. I have one which we haven't really touched upon right now, but AI frameworks do play an important part in the book. So there's I think a larger chapter covering this topic. Why did you pick the frameworks you picked, and how do you see them, work with Neo4j? What is their what is your integration idea behind it, basically?
So the book covers three frameworks. One is Haystack, another one which is Python based. The other two are Java based, which is LangChain 4j and Spring AI. So how we, I mean, it was also kind of a request and a ask from our publishers that we should cover these frameworks, but we also realize that there's a need to talk about these frameworks, and these are our individual strengths as well. I mean, I work a lot on Python. Ravi works a lot on Java. So we thought, okay, if you're talking about Python, it makes sense to talk about Haystack rather than LangChain as a framework. Why Haystack? I mean, it's fantastic for experimentation. You can build like quick prototype pipelines for your embedding, retrieval, and re-ranking. You can plug in Neo4j in as a retriever for your hybrid or multi-hop search. And if you really look at the Haystack's entire structure and how it fits with Neo4j, Haystack structure is almost similar to graph structure. It's pretty much the same. So you don't feel a disconnect over there. You don't feel a need, kind of like that you're force fitting things or you're adding things just for the sake of it, but rather it just comes naturally that you're thinking in graph way with the Haystack. I think Ravi can comment on LangChain 4j and Spring AI. He works a lot in the Java world, and I'm sure he would have some thoughts on LangChain 4j and Spring AI as well.
Yeah. So the one of the other reasons looking at Java is actually a lot of applications are building in Java. So data scientists, they love their Python, but most of it is experimental and deployment, other aspects of it. And Python comes with a plethora of ML frameworks. But there are actually quite a few scenarios where I don't want to use all those data science frameworks, but I need to fit into an application workflow. So that's where the Java can come into picture. So this is the Spring AI and LangChain 4j. Both of them are excellent framework. LangChain 4j is actually more robust framework. Spring AI is new in that sense, but both of them give ability to build LLM based applications in actually very simple manner. Even if you look at the code, the LLM integration is just maybe few hundred lines. That's it. We are able to integrate into that aspects of it and put those things, and the whole workflow aspects of it. How does that workflow works is because with LLM, the amount of data actually I'm processing in that whole workflow aspects of it is actually huge. The database is around 50 gig total database, Neo4j database sizes, with because we have almost a few hundred million transactions we are working with. So how does that work? So we want to look at actually as a, once I submit a request, how is it going to work, and other things, how is it going to give a feedback. So LLM, the Java frameworks actually will help you to be able to build those kinds of applications in a much more robust manner.
Yeah.
So we wanted to give both options for developers to see how they can work with that.
Exactly. I mean, that's what the intent, that this book should have both a flavor for Python and also flavor for Java. So they
Yeah.
do not have to buy two separate books, but rather have a single book for which covers both Python and Java. But I mean, having said that, the intent was also to make sure the book is follows a, as what Manjunath mentioned, follows a nice progression, a journey, so that no matter the framework that you choose, you use Haystack today, you want to switch from Haystack to LangChain, you want to switch from let's say Spring AI to any other framework, or LangChain4j to any other framework. So no matter the framework that you are using, the core architecture remains the same, so that you understand the basics of RAG, why RAGs, what are RAGs, RAG all about, what are knowledge graphs all about, how do you model a data well, and then take them through. Okay, if you're using Haystack, this is how it works. If you're using LangChain4j, this is how it works. But everything else remains the same. It is just that the framework are just a nice tools to help you accelerate your development process, making sure that your LLM and Neo4j can connect with each other pretty well. But you can swap in any other framework and then bring in any other framework, and it would work it would work seamlessly. Just syntax will change, just few lines of code will change, but the core architecture remains the same. And that was the whole intent, that that we should not focus, like both of us, we were, when we were contemplating on what would be the right content and the chapters and everything. So we decided that okay, let's not have something very Haystack focused or framework focused, like LangChain focused, but rather focus more on the core aspects, and just have portions where we want to touch base on the framework's capabilities, so that could shine in as well in the book.
Yeah, makes sense. We have a couple of more questions from the audience, so I'd like to take that opportunity now. One question comes from Ashwar, and I think you already mentioned this with the hybrid approach, and with the combination of vector and graph, plus getting your data sets available, and data modeling plays a role into that. And question is you have all that, and then you have a chatbot, and it's integrated, and then you ask questions, and then the LLM creates an answer out of it. And then how can you make sure that there's no hallucination in there? How can you make sure that the answers you're getting back are actually fact based and not made up? Is that something you can guide us on?
I will let that question go to Sid. I will take the ontology one.
Okay. Awesome. Okay, so
Okay.
I mean,
That's fair.
there are ways as a developer that you can put some best practices when you're building such application. So the best part about knowledge graphs in general is the explainability part of it. If you get a response back, you can also trace back to the source node. You can see where the response is coming from, how the response is being generated. Now that gives, as a developer, that will give you some sense of understanding whether the chatbot is giving you right results or whether it has hallucinating, so that you can go back and maybe fix the graph if needed, or maybe fix the data if needed. I mean, whatever the process needs to be done to ensure that the results are consistent and accurate, you do you do that. The second thing is also a feedback mechanism, a feedback loop, and that's where the agents also shine in a bit. Where if you kind of get a response, you start doing an upward or a downward. So if a user upvotes it, it gets into the feedback loop, and then The other users who ask somewhat similar questions, you start getting somewhat similar responses as well. If you downvote it, the other users will not get the same result, and you would start seeing a better result. So you can start updating, and back from the back end, a developer can go back and see what were the questions when it was upvoted, what were the questions that was downvoted, and make sure things were corrected in the course of action. I think there's no direct way to say whether the LLMs hallucinated or not. If you know the data well, then you can put some additional constraints and guardrails at the back end to ensure the responses are consistent. But there is no 100% accuracy that you can achieve. I mean, to be honest, I feel saying 100% accurate results is a myth. It's nearly accurate. It's almost there. Responses are fetching in from your data. If you're, and again going back to the same thought, that if you're modeling a data well, if your graph is modeled well, and you have the right information in your data, you have made sure that your prompts are done well. You have given enough guardrails to ensure that if someone is trying to exploit the system, there are some guardrails and checks to it, and then I'm sure that the results will not go wrong. The responses will not go wrong.
Yeah, I mean, 100% accuracy is basically, impossible. But yeah, in this scenario at least. But I think you can get close enough, and then we can always improve processes and make sure that the responses are as close as we can get them to be. Yeah, you already teased the ontology question, Ravi. So let's have
Yes.
it. Jorge or Georgie, I don't know, asks, do you consider an ontology essential for a RAG architecture, for example, for a scientific domain system, especially if we plan to integrate it with other domains like chemical, physical, or geological domains?
Yeah, the ontology, I would say it's a good to have, but not necessary, because the graph structure is sort of follows into that aspects of it. But in quite a few scenarios, actually, ontology will help because it gives a good starting point, some of those aspects of it. But there are scenarios actually where it becomes too rigid, and your data may be way too structured. So that takes out ability to look at actually data in a different way. So sometimes we want to look at a little bit differently the same data. So we want to add some extra relationships or maybe introduce some few other aspects of it into the data. So that sort of breaks strict ontology aspects of it. So ontology is a good starting point, I would say, but you want to see actually, can you go beyond ontology so that you will be able to understand your data a little bit better, and maybe you want to see add extra context to the data so that you can analyze it better.
Yeah. There was a question earlier about, what if you use an LLM to generate a graph, or if you use some kind of helper system to generate a graph, how do you define what's becoming a model and what should become what should become a node and what should become a relationship? I guess in that scenario, when you say, okay, I have no clear structure, I have no defined data model yet, an ontology could help me make sure that I don't create a lot of a huge mess, I guess. Yeah.
That's correct. It will give you a good starting point. It lets you start looking at the data and these things, but don't stop there. You want to look at actually what other information I can add into that will help me to understand this information in much better way.
Cool. Thank you for that. I had one more question written down, so I'll shoot that over, and then we see if something else comes in. Because you already included cloud deployment guides in your book, and I wanted to know, what is in your mind, what is the most important things to consider there when building AI or in the cloud.
The deployment aspects of it, especially with Neo4j, is actually because its architecture, it can start as a single server. easy to deploy, go from there. But if you are looking at large amount of data sets of these things, we have to think through how we can look into those aspects of it. This is where actually Sid added few of the cloud deployment aspects of it. So before that, we need to think about actually what would be my deployment architecture. So few of those aspects of it we may want to think uh, before going into deployment, because large data sets, large databases, their deployment architectures can become pretty complex.
Cool. Yeah. Very interesting. Thank you very much. We have another question from Desiree. She asks, you mentioned embeddings into the graph properties, the graph V and E properties. What is meant
Vertices
by
and
this?
edges. Yeah, nodes and relationships. Think of it that.
Yes. Yeah. Okay. Super.
Okay. So no, the embeddings actually, so when we are storing the embeddings into the graph database itself, it is, let's say I'm taking a structure of it and generating an embedding out of it. So embedding is just a context that represents that whole structure. So it is nothing, it's not like weights actually. So the weights are more about actually, okay, if A is connected to B, what is the weight of that connection? That's where the weights come into picture. Embedding is actually representing a big structure. It's not just one value. It may be a set of values we are trying to convert into an embedding so that I can compare a structure A is similar to structure B or not. So that's where the embeddings are. So the embeddings, we save it into database so that we can use those embeddings to be able to run, let's say, similarity algorithms or community detections. There they will help us more, persisting them.
Okay.
Ravi, do you want to also talk about, let's say, node embeddings versus vector embeddings?
Oh, node. See, the node embeddings actually, see, because again, it's a structure actually. So what we are trying to do is, when you do node embeddings, actually, it's a graph data science aspect of it. So a node embedding is actually pretty much similar to a vector embedding, but vector embeddings are actually, you may be generating them using a different approach aspects of it. So the node embeddings is, let's say I want to generate a node embedding of something. So the GDS algorithm, it traverses to a set of nodes. Based upon those nodes, it generates an embedding, and so that it can be used for the similarity and algorithms. Whereas when you say vector embeddings, actually we may be generating that vector using a different means. So simple example is for the recommendation application, which in the book we are talking about. So what we do is, we take the purchases for a given time period using LLM to summarize it. For that summary, we generating a vector embedding from LLM and saving that. So that vector embedding represents the customer purchase characteristics for a given time period generated via LLM, not using the graph data science algorithms. So, but both of these embeddings are used maybe to drive the next level of graph data science community detection algorithms, so that we can group these people together. So embedding represents a structure.
Okay. Desiree adds an add-on to the question. So, like isomorphisms, is that
Isomorphism.
something? Yeah.
Isomorphism is okay. Are these two things similar? So vectors, especially, we are using embeddings to understand actually how two things are similar. Mostly that is used for that purpose. So even vector search also is, that's all it is. So is this vector is similar to that other vector? So it's like you are drawing on a graph actually. So a vector 1 is a line in xy coordinates. Vector B is another line. If they are similar or same, actually, their value becomes actually a 1. If it's something is 1, they are exact same vector. If it is 0, they are completely opposite sides. So the how close am I in xy coordinates aspects of it? That's what the vector says actually. So if it is, for example, if ABC is one vector, ACB is another vector. Depending upon how you are creating that vector, if you say, if you are looking for only the characters in the thing, they are exactly same. But if you look at the position of the character in the string, then they are different vectors. But they may be close, but they're not the same.
Yeah. Okay. Yeah. Thank you very much. That makes also sense. So since we're coming towards the end of the session, I just have one more or less open question to you both. It's like, okay, people, if people are now curious to read this book, or if people maybe have already read the book, what's in your what can you recommend as a, I don't know, next step maybe, or where can people, benefit or take this into action now that one day when they read the book? Is there something you would see as a ideal way of the to stay in the image of the vector, like your book is this vector, what's the closest other vector there to look at?
When we started the book, agents were not, if they were there in infancy, now they are exploited. That would be one of the next things actually. So where does this go? How does let us say, if the same recommendation application I'm building, let's say if the agents are in the picture, how does that application would look like? What is the architecture I'm going to look at? So that's where few of the nuances that come into picture, but the approaches themselves are actually pretty much standard. So I'm using a vector, I'm using graph data science algorithms, but how they may get triggered, how may they communicate together, that's where the agents may play a bigger picture in terms of flows.
Yeah, that makes sense.
Yeah, I mean, if they have already, for folks who have already read the book, I must say and congratulate you that you have already crossed one journey. You have already learned a lot about graphs and GenAI. You're in a way a graph expert as well, to some sense that you understand the concepts. But what would make a difference to us as writers, as authors, would also be that how do you convert those concepts into practice? So is there any interesting stories that you have done any project after reading the book, implemented anything? Could be a small one, a passion project, anything is fine. Just share it with us. We would be happy to amplify the word. From our social handles, personal social handles, I'm more than happy. I'm sure that we would also be happy to do that. Um, and I'm guessing Alex can also help us promote
Absolutely.
it on Twin4j newsletter.
Happy to do
There are
that. Yeah.
activities, where we can amplify it, talk more about it. So, and even if you have not read the book and you still have an amazing graph story, amazing thing that you have done with GenAI and graphs, make sure that you send it across our way, and we would be happy to throw some spotlight on it. So my only request and advice to anyone, be it during my sessions or during, like for the book or for anyone, is to make sure that you put these concepts into practice. That will make our life also happy in some sense.
Yeah. Cool. There's it's not a question. It's a bold statement from Yuri in chat, and Yuri says the time has come for multi-tool MCP agents to replace applications that use frameworks.
I can take this one. This is pretty interesting. Sorry, Ravi.
No, go ahead.
I'll let you add on this as well. Well, yes. I mean, multi-tool MCP agents have really taken over. Uh, but I still feel that there's a long way to go for these multi-tool MCP agents. I Just to put that over there, I love agentic AI and what the MCP is doing. It's literally transforming the entire industry, bringing all these multi tools, and then. Uh, but I still feel that the frameworks will not get deprecated. I have a strong feeling on that. There still will be the need for frameworks. You want to build a full-fledged production-ready application. I wouldn't say that you cannot use MCP for that, but still there are some shortcomings for it. You should rather think of building something with frameworks that give you more control, an edge over MCP agents where you might not have too much of control as well. So that's what my personal thought is. Ravi, I'll pass it on to you and to hear your thoughts as well. We never had this discussion, by the way, so this is new for me as well.
It's when I see that statement, I remember Yak. Yak, if people who don't know, it's a compiler. So you want to have a compiler, but you want to build this thing. You need a tool to build that compiler. So it's like frameworks won't be disappearing because MCP server becomes that framework, or they are running on a different framework. So it's about how we are going to use those frameworks is going to change MCP servers. They are going to change it drastically. But the frameworks themselves, you need a framework to be able to build another framework.
Yeah, I agree. I think you can benefit a lot from MCP multi-tool agents, but some tool has to it's in the word already. Multi-tool. Without the tool, the agents running is not doing anything. So you need a tool, and that tool probably needs. But it will make things lots easier to orchestrate and to get things together, because it's just this one, instead of multi frameworks that are not standardized across each other and don't really work together. You have this one standardization through the MCP that then enable you basically to get the ball rolling quicker and easier.
I'll also like to give an analogy over here. So when no-code solutions or low-code solutions came into existence, um, people started getting scared with the fact that these no-code solutions or low-code solutions will take away the jobs, or even with vibe coding for that matter. These days, these will take away the jobs, or these will be the next big things. And then I'm again not disregarding what they have done, all these tools and no code tools, but still the existing frameworks, languages, they still exist and they're still used despite the fact that these no code tools or no code frameworks exist, low code frameworks exist. So it's the same analogy over here as well. I mean, the the frameworks will give you more control. You can build things from scratch, but yes, MCP tools and agents can just help you in quick prototyping. So you need to choose that what you really want to do. You want to build an application which you can deploy, you can use it, or you just want to have small prototypes. That's what I feel that one should think in that direction. For just testing the waters, you want to see how things work. MCP tools and agents are amazing, but still, you would definitely need frameworks if you want to have better control.
Yeah. And then maybe to round this up, because Jorge added another addition to the ontology bit, and it said you create a schema maybe, and then you have the instances created in Neo4j with sets of relationships and properties and nodes, and then the semantic analysis performed by the LLM could have more context. And he thinks if we add external information to our schema, but in the same format, and he suggests a turtle file for just like RDF space. And I think Jorge, I think you don't have to switch toolage again. You can add all that in the graph. You don't have to bounce around with things. So you can from your baseline graph, and that's what I think Ravi you mentioned it before, is it don't stop at the initial ontology bit. Add around it, add your, and that doesn't have to be a turtle file only. It can be your knowledge, your files, your structured and unstructured data, and add it onto it, and then you create this trove of knowledge, this true knowledge graph, I guess. And then from there, you enable an LLM to get the context, get the information, and then you have, and that's what you said earlier. It's like you edge ever so closer to this 100% accuracy for your application.
Yeah, because that's what it is. One thing with knowledge graph is they are living things. You are enhancing them every day. every information actually. So let us say you have a between two entities with this thing. Now you have a new context, new understanding of the data. So between the existing new nodes themselves, you just add one extra relationships that gives you new context to that thing that was not there in the original data. You are enhancing, you are adding that thing. So that's how we should look at the knowledge graphs. Are actually, they are evolving things. As my understanding of the data is evolving, the graph is evolving with me. So that's why they are very, very powerful, because you cannot do this way with relational databases. It's not easy to do that.
Yeah, absolutely. Cool. Yeah, I think that is the time we have, and it brings us to the end of the episode. Thank you very much, Sid and Ravi, for joining me today for this this Q&A on your new book that's been out. The link to the book, and I should share this one more time in chat. Give me a second, and I'll pop it in there. Is available for you all to buy and to have a read. So I'll encourage you to do that. I think it is a great book to learn more about how to develop a knowledge graph application with an LLM in mind. So that's a great source.
Thanks, Alex.
If you're interested in more than Road to Nodes, I think we teased it a little bit at the beginning. Nodes is happening in November, but Road to Nodes is kicking off actually next week. Can you believe it? On the 18th of September, we start a weekly, I think it's weekly, yes, a weekly series until end of October with 7 workshops. We start with Neo4j fundamentals. So if you are no way knowledgeable about Neo4j, this is a great place to start. And then we dive into various AI-based workshops. They are all about 2 hours long and vary in terms of we do something with GraphRag, we do some hybrid retrieval, we do agents, we do MCP. So we cover a wide range of topics. So if that's interesting to you, check out the link. I put it in chat, also the video description on YouTube, and subscribe to one or more of these sessions. Nodes is here, and then great question in chat. Great session. How do I learn more? This as if on cue. this is where you go to learn more. It's our GraphAcademy, where we would encourage you to learn more. There are courses on GraphRag, but also on generic Neo4j courses. So this is a great place to learn if you want to get hands-on. If you want to dive in right away, Neo4j Aura Free is the suggested method for you. You don't have to install anything, you have to maintain anything, you don't have to worry about anything. You just set up an instance that's free for you, and then you can start building. And if you want to learn more about documentation, tutorials, how to build with certain languages, how to do some stuff with AI, then our developer pages are a great way for you to find these things and see resources across the board from all kinds of topics. So I think that's the best way. And you can also check out our community on Discord, on the forums, if you have questions, if you are stuck with something, and find like-minded people and to exchange ideas and concepts. So thank you very much again for watching. Thank you, and particularly, obviously, to my guests, Ravi and Sid. Thank you for being here today. Thank you for writing this book. I think that's amazing, and hope to see you with the next book. I know, Ravi, you've been here with the last book you wrote. Now we'll see the next book. We will have you here again.
Okay, thank you.
Thanks, Alex.
Thanks,
Ravi.
Thanks, Ed. Thanks.